Okay, so we're just going to jump in right where we left off. Number 6, the x and y intercepts. So remember to find the x-intercept. You're wanting to find the x value when the y value is 0. So you're going to take what you're given, and instead of writing y, you're going to plug in 0, which of course essentially just cancels it. So you get 4x equals negative 20. And when you divide by 4, you get x is negative 5. So negative 5, 0 is one of my ordered pairs. And I can graph it. All right, the next one is your y-intercept. So similar idea here, except for we're going to plug in a 0 for the x and solve for the y. So when I plug in a 0 for the x, I get 4 times 0 equals 6y minus 20. So I'm going to break this down. I get 0 equals 6y minus 20. I'm going to add 20 to both sides. And then I'm going to divide by 6. 20 divided by 6 reduces 10 thirds. So that is like 3 1/3. Let's see, there's 3 1/3 would be about there. Oh, just kidding. That was silly. That's my y-intercept. Just kidding. Okay, 3 1/3 would be there. And then you can connect those to make your line. So mine's going to be a little wobbly. Hopefully you have like a straight edge or something to use to make yours a little bit prettier. But it's going to end up looking something like that. Okay, ready for number 7. Graph the inequality on the grid. Write the steps you use to graph. So you're just kind of breaking this down a little bit according to probably the easiest way to approach this would be kind of like a slope-intercept kind of approach. So we know that our y-intercept is 0, -3, and that's where we're going to start. So down here at 0, -3. And then, of course, we're going to use our slope to rise over run. So from that point, I can go up to right 1. And I can do that several times. I could also go down to left 1 just to get that same slant, because that's still negative divided by negative is a positive. And then when we notice this is an inequality, so we're going to use the dashed or dotted line. So you're going to kind of do something like that, and then put your arrows. And then this greater than symbol means that we're going to shade above. So go to where your y-intercept is, and then you would shade above that. So that means we're shading everything over here. So we just want to show that this is where the solutions would be on this side. Okay. Looking at number 8. Devontae is purchasing a box shaped like a rectangular prism. He knows the volume is found by using the formula V equals length times width times height. He needs to check the length of the box, and so he needs to rearrange the formula to solve for L. What is the formula he needs? So we're taking this formula and we're solving for L, so we have to ask ourselves what is happening to L. Well, L is being multiplied by WH. So to undo that, we are going to divide by WH. And of course, what we do to one side, we have to do the other. So we end up with volume. Oops. We end up with volume over WH equals L. So we got L by itself. All right, number 9. A right triangle has side lengths that measure 7, 10, and square root of 14. What is the difference between a rational and irrational number? Okay, so this is where you're using that vocabulary. You could word this in several different ways, but you might want to say something like a rational number can be written in fraction form, whereas an irrational number, like a repeating, or excuse me, a non-repeating, non-terminating decimal cannot be written as a fraction. Letter B, is the value of the perimeter of a triangle rational or irrational? Well, if we were to add all of these together, remember perimeter is your distance around a figure. So like if you just had a right triangle, your perimeter would be the distance all the way around it. So you would add the 7 side, the 10 side, and the square root of 14 side. And this could reduce to 17 plus the square root of 14, and then of course we could use our calculator and simplify this to a messy decimal. And what I mean by messy decimal is it's not going to be terminating, it's not going to be repeating, so we know that it is irrational. Is the value of the area of the triangle rational or irrational? Well, let's look at the area formula for a triangle. So you know that area equals 1/2 times base times height. So the biggest side is going to have to be the hypotenuse. So if you wanted to square root the 14, you could see that it simplifies to about 3.74. So I know that this side is my hypotenuse, the longest side. So that means that this side and this side are my base and my height. So again, you do have to know some basic geometry, probably 7th grade geometry, to understand, guys, remember a right triangle, oops, if I can draw one, has your one right angle, and then the longest side is your hypotenuse. So what we have here is a right triangle with a side length of 7, a side length of the square root of 14, and then a hypotenuse, or the side opposite the right angle, is 10. So when we're talking about 1/2 times base times height, we're looking at this. And really all of this is going to do is we could divide this product by 2, but the square root of 14 divided by 2 isn't going to turn this into a rational number. It's not going to make it a non-messy decimal, so to speak. So to simplify this, we could say something like the area is 7 square roots of 14 over 2. But again, that's still going to be irrational. And if you want to explore that further, type it into your calculator, see what kind of decimal you get, see if you can get your calculator to turn it into a fraction. You can work on it for a couple minutes, see if you can get it turned into a fraction, but it's not possible. All right, letter B, building on this, a square has side lengths that measure 10. So again, think about what you know about a square. We have a 4-sided figure with 4 right angles, and all sides are congruent, side lengths of 10. Is the value of the perimeter of the square a rational or irrational number? Well, perimeter means you add all the sides. We have 4 side lengths of 10, which is just 40. If we want to see if 40 is rational or irrational, well, can 40 be written as a fraction? And yeah, you can write 40 as a fraction pretty easily, 40 over 1. So that is rational. Okay, letter B, is the value of the area of the square a rational or irrational number? Well, okay, area of a square is side length squared. Squared there. So 10 times itself is 100. So can 100 be written as a fraction? If so, this is rational. And of course, we can write 100 as a fraction just by putting a 1 under it. So this is rational. And finally, letter C, if the side lengths are changed to square root of 10, so now we have a square, all the side lengths are square root of 10, will the perimeter and area stay rational or irrational? So the area would be the square root of 10 plus the square root of 10 plus the square root of 10 plus the square root of 10. It'd be 4 square roots. Oh, sorry, the perimeter is what I'm talking about here. I'm getting ahead of myself, guys. I'm sorry. Let me back up just a minute. Perimeter is our distance around. So that's square root of 10, square root of 10, square root of 10, square root of 10. So I have 4 square roots of 10. And again, no matter how you enter this into your calculator, it's going to stay irrational. It's a value that cannot be written as a fraction. So the area, though, on the other hand, is side length squared. And if I take the square root of 10 and square it, you guys know from your opposites, adding is the opposite of subtracting, multiplying is the opposite of dividing. We know that squaring is the opposite of square rooting. So the area of this square would be 10, which can easily be written as a fraction. So the area here is rational. All right, number 10, the function f can be used to represent the relationship between the ounces of water remaining in a fish tank after s seconds of draining at a constant rate of 4 ounces per second. A represents the amount of water in ounces in the tank before it drains. So A is like our starting amount. Write a function to show the amount of water in the tank after s seconds. So we start with this much water and we decrease by 4 ounces each second. And that gives us our function, or our amount remaining in the fish tank after s seconds. This information, the tank is completely drained after 90 seconds. So basically what they're telling you is the amount of water in the tank will be 0. So when will f of s be 0? Well, the tank will be empty. In other words, noted by f of s equals 0 after 90 seconds. How many ounces were in the tank at the beginning? So if we're draining to 0, we want to see the beginning here is A. So what we have here is we know that A minus 4 at 90 seconds gave us 0 water, so an empty tank. So basically I took this as an ordered pair, which was 90, 0, input, output, and input that in, and now I can use that to solve for A. So A minus 360 equals 0. Add 360 to both sides to get 0 by itself, and it appears that there were 360 ounces in the tank to start with. All right, this mapping shows the relationship between these variables. Which of the following equations are true? So basically this is an input and this is an output. So it's saying when x is 2 is y 2. Well, here this is showing when x is 2, follow the arrow, y is 6. So this is false. Well, when x is 3 is y 9. 3 goes to 7, so that's false. F of 4, which is 7 times 7, equals 49. That is true. So if it's asking me to select the true, then I know that one's true. F of 3, which is 7, plus 5, is that 16? Well, no, that's 12. So that one's false. And f of 2 plus 2, f of 2 is 6, plus 2, does that equal 4? No, it does not, so that one's false also. So quite a few false there. Only letter C was correct. All right, number 12, use the function to answer the following questions. So at this point, we'll go ahead and pause or stop this video and see part 3 for numbers 12 and on.